So this is P over 2. Over here is minus what? P over 2, right? If we were to construct bending moment diagram, we know the bending moment diagram looks like this. So where failure will occur at this point. Yes or no? The shear force and bending moment diagram just show you the failure in what view? The XY view. Then next we go into detail. We look at the side view now. We look at the cross-section view now. All right, we look at the cross-section view now. And then we draw the what? We draw the centroid. You and me know where will tau max occur. Evans! Tau max will occur where? Centroid. I'm helping you here. Don't panic, okay? Evans is like, Evan, don't buy drugs to calm you down, okay? It's me, okay? It's not you, okay? So you know that over here is tau max. Yes or no? But this is made out of how many different parts? 4 different parts. They are held together by those fasteners on the side. So that region is known as our what? Joint. At the joint is where things are the weakest. Okay. And now you remember our friend for front. The example when you put clear? Yes. So if you look at the circle, and it's like under that equation. We just look at the magnitude. We just look at how the shear force is going. Positive shear and negative shear don't affect. Good point, but I'll bring it up when we do more of the y is square, so that's but it's quicker with the negative outside would be the negative backside. But the whole value we end up at the outside would be negative. Right. Are we clear? Okay, what are we clear about is the failure region. So the next thing is there are rules that we have to comply. Okay, so most important thing what you learn from today is that failure will occur at the joints. Okay, failure will occur. So the formula that we're going to apply, still the same set of formula. That the shear stress is equal to VQ over IT. By the way, just to let you know, I did a lot of consulting on this work, okay? In my previous house, I got my deck built free because I did a big calculation for the decking company, okay? So this is equal to VQ over I. Did the formula change? No, do the same. All the 7 rules still must apply. Are we clear? You still have to design the shear flow, the web control the shear flow, still the same. Now, the next thing I'm going to have the formula that Q can be equal to is equal to the fastener resistance force divided by fastener spacing. Okay. Fastener resistance force divided by fastener spacing. The units on the left hand side. So this is Newton meter cube over meter 4. You cancel Newton per meter. Fastener force resistance Newton divided by what? Divided by meter. Okay. Now for longitudinal shear, we must include two more rules. Number one rule is that the member must entirely distribute the shearing stress. And number two is that the fastener, the joints or fastener is used to transmit the shearing stress or shear flow from one member to another member. Now, what does this actually mean? Okay, I mean, rule number one, you guys, okay, yeah, member must entirely distribute. Number two, then the joint of fasteners is used to what? Is used to transmit the shear flow or the shear stress from one member to another member. What does it physically mean? Okay, so if we still look at the same cross section, okay, so this is known as my member number one. Member number two, member number three, and member number four. Okay. So if we were to focus into member number one, and you have a Vy acting from the top. Okay. The shear flow, okay, the shear flow, sorry, yeah, I can draw it sideways. No, I cannot draw it sideways because it's thick wall. The shear flow has to, or the shear flow, the Q or tau has to distribute across the entire, okay, the entire cross section before transmitting by the what? By the fastener. Okay. Now this is a very important point. So the shear stress will distribute entirely across the what? The member first. Then after that, when you have your fastener, the fastener then will transmit to the other member. Okay, then it will transmit to the other two members over here. So this is your member number 4, and this is your member number 5. Now, why this is important, anyone, is to help us to calculate what? First moment of what? So why is this important? Some of you might, if I don't set this rule, what is going to be confusing? If I don't set this rule, what is going to be confusing? If this rule is not set, you will visualize this way. If this rule is not set, that the entire member has to take the load first. If I don't do that, you're Eugene. If that's the case, why not we just, because your fastener is here, right? That's the axis of the fastener, yes or no? Why not we just take this area? Why do we need to take the what? The bottom. You look at the fastener like a channel. Only when the entire section is distributed with the shear flow, then you will transmit via the what? Or the joint. Okay. You have to set rules like that, because if not, you say, Eugene, there's the fastener, you know, why do we need to consider this is the rule that you have to find. The correct thing to do, so this is wrong. Okay, this is wrong. This is wrong. Okay, this is wrong. You have to take the entire what? This is correct. You have to take the entire what? Member number one, the entire area. Are we clear? Okay, now listen. Don't be too worried about whether you pass or fail the content. Are we clear? Okay. I hope to get the result out to you all by this evening. Okay. So that's the case. Have a good weekend.